Hi, my name is Jefferson Hall, and today we're going to be talking about electrical connectors. A lot of people ask me, how do you make a good connection? And some even ask me, what is an electrical connector? And what is its purpose? Well, to start off, basically, an electrical connector's purpose is to do really two things. One is to conduct electricity between two conducting mediums, say two wires, and two is to also satisfy the mechanical properties of that connection. So say you have a wire hanging in the air, that connector needs to be strong enough to hold up that wire. And there's a third thing that's pretty important, probably even more important than the other two, is that it needs to do it for the intended life of the application. So there are three keys to making a good connection, and all three of them actually interrelated. The first one is choosing the right material. Material that's aluminum, you want to connect aluminum, you should choose an aluminum material. The second is maximize the amount of electrical contact area between the two conductors. And the third is maximizing the pressure or force that's used to make the connection. If you lose any one of those three keys, over time, that connector is eventually going to fail. So let's dive a little more into the choosing the right material. These recommendations are only recommendations, there are exceptions to them all, but these are the right materials that we recommend for longevity, especially in utility applications. The first is, if you have aluminum conductor, you're going to connect aluminum conductor, you want to use an aluminum connector. If you're going aluminum to copper, you would use an aluminum connector. And if you're going from copper to copper, we recommend using a copper connector. There are exceptions to this rule, but when in doubt, copper to copper, use copper. Second, let's talk about maximizing electrical contact area. Picture taking a microscope and looking at the surface. What you would see is basically a big mountain range. And where the peaks of the mountain range on one conductor hit the peaks of the mountain range on the other conductor, that's where you have electrical contact. And the rest of it, if it's not touching, it's not conducting electricity. So the third key actually helps with the second key, in that's maximizing pressure. By maximizing the amount of pressure, you can actually create more electrical contact spots at the molecular level. Notice that I say optimizing pressure. Have too little pressure, you won't create any electrical contact spots. If you have too much pressure, you may actually deform the material. So having the optimum amount of pressure will give you optimal electrical contact spots without damaging the connector or the conductor. Now let's talk about the things that want to reduce the life of your connection. The first one is more like operator error. One, either the connector was installed incorrectly or the wrong connector was chosen for the application. The second is about Mother Nature. There's a couple things that will attack your connector, and they all have to do with Mother Nature, and most of them have to do with corrosion. And there's a third thing that has to do with the application itself, and that's thermal related. Oftentimes a connector, because it's carrying current, will heat up. And that heating up, if it heats up too much, will reduce the life of the connection. We'll get into why that is in a minute. So let's talk about corrosion. There's two different types of corrosion that will affect your connection. The first one is oxidation, and the second one is galvanic corrosion. Oxidation is a form of corrosion where the metal reacts with the atmosphere, particularly the oxygen in the atmosphere. Let's talk a form of oxidation that many people are already familiar with, and that's rust. So iron that's in steel will react with oxygen, and that oxygen basically creates what we normally call as rust. Same thing happens with aluminum, but instead in the case with iron, where the rust keeps falling off and eventually the part will rust to it's nothing. Aluminum had a benefit in that the aluminum reacts with the oxygen and creates a protective coating that limits the oxidation from eating basically the aluminum. Problem is that layer is an insulating layer. So if that layer is not removed prior to making a connection, you actually have an insulative layer inside your connector. So it's important that when you're making your connection that you remove that oxidation layer prior to installation. And the best way to do that is with a wire brush. One of the major causes of failure in electrical connectors, particularly in the utility overhead application, is the aluminum oxide was not removed prior to installation. So by wire brushing, that's the simplest and least costly way to remove that oxide. And in general, you only need to wire brush the conductor. Burndy aluminum connectors are specially treated at the factory to remove the aluminum oxide from the surface, and then they're sealed. So by the time they get to the site, there are no aluminum oxides on the surface. In fact, if you feel the connector, it feels a little waxy, and that wax coating is actually protecting the connector, so when you install it, it will give you a long-performing connection. A lot of people ask me, do copper conductors need to be scratch brushed? When in doubt, wire brush the conductors, whether it be aluminum or copper, wire brush. There are some conditions where you don't need to wire brush, and in fact you should not wire brush. One of them is with tin-plated surfaces. Another one may be a silver-plated surface or any really plated surface. No wire brushing is required. If there's insulation, don't scratch brush the insulation. We talked about oxidation affecting your connection prior to installation. Now let's say you've installed the connector, you've done the wire brushing, you've installed it correctly. Now what happens? Mother Nature will infiltrate the connector and try to make the connector fail prematurely. So the way we combat that, or the way we reduce that, is using oxide inhibitors. The purpose of an oxide inhibitor is to reduce the amount of oxygen that can ingress into the connection and essentially increase the life of the connection. So oxide inhibitors are basically made of grease, and they have also other proprietary ingredients into them to actually help improve the connection itself. But the purpose of the grease is to keep either moisture or oxygen from getting inside the connector, and by doing that, increases the life of the connection. Another form of corrosion is something called galvanic corrosion, where you have two different metals that are at different potentials, electrical potentials. Say, for example, aluminum and copper. In this particular case, you have what they call an anode, which is the aluminum, in contact with the cathode, which is copper, in the presence of an electrolyte. And that electrolyte can be water, could be salt water, could even be moist air. What happens is the electrons, because there's a different potential between the copper and aluminum, the aluminum gives up its electrons to the copper and essentially starts losing material. In other words, the copper starts to eat the aluminum. If you have a bimetallic connection, say copper conductor being connected with aluminum on the seacoast, and you don't have oxide inhibitor present to keep out the electrolyte, that connection is going to fail due to galvanic corrosion very quickly. So is it possible to reduce that galvanic corrosion? And the answer is yes. The easiest one to do is use the same materials if possible. So if you have copper to copper, use copper. If you have aluminum to aluminum, use aluminum. And when you do have copper and aluminum, we recommend using aluminum with a large amount of oxide inhibitor. If there's an abundant amount of oxide inhibitor that prevents Mother Nature from getting into the connection or having the electrolyte getting into the connection, that will reduce the galvanic corrosion. Another way of reducing galvanic cell is by plating the cathode, in this case, plating the copper. Another method of reducing a galvanic cell is to use insulation. And the last one that is often used, and this is why we recommend using aluminum for an aluminum to copper, is using a principle called the mass anode principle, where if your anode is significantly more massive than the cathode, the rate of corrosion is significantly reduced, so that it basically reduces the amount of corrosion over the life of the connection. There's a term in the industry called know your ABCs, which means aluminum above copper. And basically what that means is whenever you have a bimetallic installation and it is going to be exposed to the elements, you want to keep your aluminum above the copper, so that if a galvanic cell is created, the cell is beneath the aluminum conductor, and the mass anode principle will take effect and reduce the galvanic cell in the bottom part of the connection. Another threat to the longevity of your connection and the performance of your connection are thermal effects. When current runs through a conductor, the more current that runs through it, the hotter that conductor gets. And same thing happens through a connection. The more current that runs through a connection, the hotter that connection gets. And in most cases, as metals heat up, they expand. And then as they cool down, they contract again. That repeated expanding and contraction between two metals will reduce the life of the connection. The more current that runs through a conductor, the hotter that conductor is going to get, and the hotter the connection is going to get, which will reduce the life of that connection. So one rule of thumb is never to put aluminum conductor inside a copper compression connector. the connection will fail very quickly. One of the benefits of Burndy products is that Burndy designs and manufactures all its own connectors, tools, and dies. And they're all tested per industry standards, so that when you use Burndy tool, connector, and die, you have a connection that you can rely on. Thank you. That's all we have for today. My name is Jefferson Hall, and thank you for joining me. If you have further questions, please contact your local Burndy sales rep or go to Burndy website, www.burndy.com. And that's all we have for today. See you next time.